Hi everyone, good day. My name is Madhuri Suresh and I'm the Senior Data Center Trainer at Nitiz Sharma Global Tech Private Limited. Today we're going to be continuing with VPC. We have already dropped a couple of videos in the VPC series. So you can click on the I button above so that you get access to the previous videos. Today we're going to be discussing about a couple of advanced features that you can configure in VPC. These advanced features are also considered as the best practices, so it's always recommended for you to go ahead and enable them. The first one is peer switch. Now, what is peer switch? So by default, what happens is between the two peer devices, as you all know, as we have discussed also, there is an election process that takes place. One of the device gets elected as the primary, the other one becomes the secondary based on mainly the role priority or the tiebreaker, which is the MAC address. Whichever is the primary device, as we have again discussed earlier, the primary device is always the main device with regards to the control plane traffic. Control plane in the sense that again VPC is layer 2. So layer 2 control plane mainly refers to ARPs as well as BPDUs. It's only the primary device that can process these traffic. If in case any control plane traffic is hashed towards the secondary, then secondary cannot process it. It does not know what to do with it. So what it will do is it will go ahead, use the peer link to forward this particular traffic towards the primary device. This is always the default behavior. So even for any of your VPC VLANs, so let's say I have configured 3 VPC VLANs here, 10, 20, 30. For any of your VPC VLANs that you have configured, if you check the spanning tree information, you will by default only be able to see the MAC address of the primary device. Okay, so this is always going to be by default the STP route. Only the primary device will be the STP route for all of the VPC VLANs that you have configured. This is the default behavior, and that's why only the primary device can go ahead and process these BPDUs. With peer switch, the secondary device also gets its capability to behave as an STP route. Again, do both primary and secondary behave as individual routes? Of course not. For one VPC VLAN or for one STP tree, you can only have one STP route, right? So both primary and secondary together are going to appear as a single STP route to all or for all the VPC VLANs that you have configured. Okay, so you go on the primary or on the secondary or even on any of your downstream devices, the default behavior is no matter which VLAN it is that you check it for, whichever VPC VLAN it is that you check it for, by default you'll only be able to see the primary device as the STP route. But once you have configured peer switch, both primary and secondary together are going to appear as a STP route. How are they appearing together as the STP route? So again, whenever you configure VPC, there is that virtual MAC address that gets generated, right? That MAC address is going to be shown as the STP route MAC address. Okay, so the peer switch basically gives the secondary device its capability to process BPDUs as well. So if in case there are any BPDUs that are hashed towards the secondary now, the secondary does not have to forward it to the primary because it is behaving as an STP route along with the primary. It can go ahead and handle it. But what about ARP? So part of the control plane is taken care of, the BPDU part. What about ARP? ARP is still or can only be handled by the primary device. Again, the main device is still the primary, but with peer switch, the secondary gets a part of the control plane, but the main device is still the primary device. Okay, so this is what peer switch is. And one more thing, just because peer switch is giving the secondary device its capability to process BPDUs, please do not enable peer switch only on the secondary device. Go ahead and enable it on both. You need to enable it on the primary device as well. Now, why should I enable it on the primary? Primary already has the ability to process BPDUs. So why enable it on the primary? Keep the role changes in mind. Okay, so if in case there's any failure and if in case one of the box goes down, you know that there is going to be a role change. So this device will change and become operational primary. This device, whenever it comes up, changes and takes over the role of operational secondary. So if you have enabled peer switch only on the device over here, then again, after the role change, anyways, this is the operational primary device. Like we have discussed earlier, there is functionality wise, there is no difference between primary and operational primary. Whatever the primary can do, operational primary can literally do the same things. So this is again taken care of, but here you're back to square one. So again, secondary and operational secondary, role-wise, functionality-wise, there are absolutely no differences. So if you do not enable it on this device, you're back to square one, right? Every time you'll have to manually probably go in and enable it. So again, it's not recommended. Go ahead and enable both the features on both your peer devices. So the second feature that we are going to be discussing about is dual active exclude interface VLAN. Now, what is this? So, if in case, let's say this is the primary, this is secondary, if in case the peer link fails, as we've discussed earlier during the failure scenarios, what happens is secondary will put its member ports into suspension state. Now, apart from that, a couple of other things also take place. If you have created any SVIs using any of your VPC VLAN, so let's just assume that I have created SVI of 10 on the secondary device, and also I'll take SVI of 10 on the primary as well. Now, if you have created any SVIs on the secondary device using any of your VPC VLANs, these SVIs are by default also put into suspension state. Okay, so in order for you to exclude these SVIs from being suspended, because again, you could be using SVIs for something important. Probably it is going to be used as a default gateway for inter-segment communication. It could be used for some layer 3 peering or anything. So in order for you to avoid or exclude it from being suspended, if or when the peer link goes down, you can always give this particular command. Again, it's very handy. Please make sure that you are enabling it on both the devices. What happens to the SVIs that I may have created on the primary? Nothing. On the primary, absolutely nothing happens if in case there's a peer link failure. But on the secondary is where all of it happens. So make sure that you're enabling this on both the devices. Again, to maintain consistency, it's normally enabled like the same SVIs would have been configured on both the devices, and you need to exclude it from being suspended when the peer link goes down. Okay, so as soon as after you have configured this, as soon as the peer link goes down, now the SVI will not be suspended any longer. It will still be up. The next feature is Orphan Port Suspend. So this is another feature that is relating to the same failure scenario. Again, whenever it is that the peer link goes down, on the secondary, the member ports are put into suspension state. And normally any SVIs that you may have created using any of your VPC VLANs, by default, they are put into suspension. But with the feature that we just discussed about now, you can exclude it from being suspended. Apart from this, if you have configured any orphan ports, so let's assume I have an orphan device here, and this is an orphan port that I have configured. If you have configured any orphan ports on both the devices, let's say on primary as well as the secondary device, again, as usual, on the primary device, absolutely nothing happens, but on the secondary device, this particular interface will be put into an error disabled status. It's not the type of error disabled status that you can go ahead and bounce the interface for and then expect it to come up. This is actually the status, you will be able to see it as active only, but it's just that that interface is not going to be receiving or sending any traffic. So traffic handling is not there on an orphan port during this particular time, and it's only on the secondary device. So let us assume that this particular device over here, of course, because it sees that the connectivity is active, it doesn't see that it's in an error disabled status or anything. It sees that the link connection is active, and this device, if in case, because it assumes that it is active, starts sending any traffic, then of course my traffic is dropped, right? So instead you can go ahead and configure orphan port suspend. Again, with regards to this, please remember that this is not a global command. It's not a command that you can enable under VPC. You will have to go to the actual interface. For example, let's say my orphan port interface over here, I'll write it over here, is 1/1. I'm just taking a random example here. You need to mention under this interface, you need to mention it under the interface level that you would like to put it under suspension state. Okay, so next time, whenever it is that there is a peer link failure on the secondary, how many ever orphan ports it is that you might have enabled this particular command on, all of those ports are going to be put into a suspension state. Suspension is better than keeping it in an error disabled status. Suspension is always better than having your traffic dropped, right? If in case or whenever it is that the port is suspended, of course this entire link is suspended, so this device will not even think about sending any traffic. So if it's not sending any traffic, then there is no dropping of traffic at all. Okay, but the thing is that you will have to go ahead and enable this particular command always under the interface level. And again, for consistency, normally in production environments, the same thing is configured on the primary device as well, because of course the role change is always kept in mind. If in case there's role change, this operational secondary, operational primary, so it's again taken care of. The next feature is IP Arp Sync. Now, what is IP Arp Sync? Again, there is a lot of misunderstanding with regards to this particular command. It's not that the ARP tables are synchronized between the two devices only if you have enabled this, but it's just that enabling this particular command is going to efficiently handle your traffic. Okay, so let us assume that this is primary, this is secondary, and you can take any failure scenario, but a failure scenario where only one device is active and is handling traffic. So it could be scenario where your peer link has failed probably. So if your peer link has failed, you know that on the secondary device there is a suspension, so now all your traffic is only handled by the primary. Or you could take a situation where the secondary device itself is completely down, or even where the primary device is down. So if the primary device is down, the secondary is going to change its role, become operational primary. All my traffic is only handled by this. So you can take any of the failure scenarios, but the point is that only one device is active and is actively handling traffic. Now, what happens right now, I'll take the first scenario. For example, my peer link has failed, so the secondary has suspended its member ports. All my traffic is handled by the primary device. Let us assume that before the failure happened, there were some ARP entries, of course, right? But now that only the primary device is active, because it's all my traffic is only hashed towards the primary device, because this is the only active device that I have, definitely the ARP entries in its ARP table might be more, right? So but during this particular scenario, there is absolutely no way that there is synchronization that is taking place between these two boxes. Because primary is the only active device, it might definitely have some updated ARP entries in its ARP table, but it has absolutely no way of synchronizing that particular entry, the new entries, with the secondary device because of the failure scenario. So secondary is just left with the old entries in its ARP table. It does not have any updated entries. Now, let us assume that the failure scenario is over, right? So the other device is also up. So now let us assume that the other device is also up, the failure scenario is gone away, so my other device is also up now. And normally what happens, or I can say by default what happens is, VPC member ports are immediately up and they could immediately start hashing traffic. Now, these member ports will start receiving traffic even before primary and secondary had a chance to synchronize their ARP tables. Okay, it's highly possible that the traffic is accepted by these member ports, by these devices, even before the devices had a chance to go ahead and synchronize their ARP tables with each other. So again, if in case the updated ARP entries are here, but then it's being hashed towards the secondary, and now the secondary is receiving traffic that it has absolutely no idea of, this is what could lead to, again, something called as an unknown unicast, and your traffic could be black hole. So in order for you to avoid that, you can configure IP Arp Sync. So what IP Arp Sync does is it makes sure that after the reversion, that is after it comes back to normal, with this particular command IP Arp Sync, it's made sure that the tables, the ARP tables are firstly synchronized between the two devices, and only then traffic is accepted. Okay, earlier without the command, traffic would be accepted without even checking if there is a synchronization between the two tables. But with IP App Sync, once it has been enabled, and again, you will have to enable it on both the boxes, both on primary as well as on the secondary devices. So once you enable them, it makes sure that the traffic is accepted only after the synchronization of ARP tables between the two devices. We will be covering a couple of other features in the next video. Please like, share, and subscribe to our channel. Thanks everyone.